LoggerConfig in Log4j. Now we are focusing on LoggerConfig. LoggerConfig objects are created when loggers are declared in the logging configuration. The LoggerConfig contains a set of filters that must allow the log event to pass before it will be passed to any appenders. It contains the references to the set of appenders that should be used to process the event. Here you can see how log level filtering works. Log configs will be assigned to a log level. A set of built-in levels include all, trace, debug, info, warn, error, fatal, off. The Log4j to also support custom log levels. Another mechanism for getting more granularity is to use markers instead. The off and all levels are not intended to be used on calls on the logging API. Specifying off in the configuration implies no logging event should match, while specifying all would mean all events match, including custom events. However, off can be used to logging API calls in special cases where the event should always be logged regardless of the configuration. However, it is generally recommended that a marker with the corresponding global marker filter should be used. Table here illustrate how level filtering works. In the table, the vertical headers shows the level of the log event, while horizontal headers shows the level associated with the appropriate logger config. The intersection identifies whether the log event would be allowed to pass for further processing. Yes, here. For further processing, yes, or discarded, no. Here. Here, all means all events should be logged. Here, trace means the fine-grained debug message, typically capturing the flow through the application. Here, debug, a general debugging event. Info, an event for informational purposes. Warn, an event that might possibly lead to an error. Error, an error in the application, possibly recoverable. Fatal, a fatal error that will prevent the application from continuing. Off, no event will be logged. Here, if we configured log level to trace, all no, and other levels, other levels are yes. And if we set the configuration to debug, no for all and trace, and yes for other levels. And if we set the configuration to info, no for all, trace, and debug, and yes for other levels. And if you set the configuration to warn, no for all, trace, debug, info, and for others, yes for others. And if we configure the logger config to error, and yes for error, fatal, and off, and no for others. And if we configure the logger config to fatal, yes for fatal and off, and no for others. And if we set the logger config to off, and yes to off, and no for other levels. As an example, we can consider class LoggerConfig, logger object that is created via configuration. This is in org.apache.login.log4j.core.config class or config package. Here you can see adds an appender and new logger configuration using that appender to the current configuration. Here LoggerConfig logger objects that is created via configuration. This is in class org.apache.login.log4j.core.config in package. Here the public static LoggerConfig create logger string additivity org.apache.login.log4j.level level and string logger name and string inclusion location where the location should be passed to downstream, and appender refs array of appender names, and properties to pass to the logger is an array, and at plugin configuration config here, and filter. This method is deprecated in 2.7. Use create logger with the boolean value here, boolean for additivity. This add appender method adds an appender to the logger config. This is appender, and this is level, and this is filter. So here in the context, the add logger adds a logger, and this is the name, and this is the logger configuration, logger config. So here update loggers causes all loggers to be updated against the specified configuration. Here you can see LoggerConfig is configured using the logger element here, and loggers are here, and the logger element must have a name attribute specified. You will usually have a level attribute specified, and may also have additivity attribute specified. The level may be configured with one of trace, debug, info, warn, error, all, or off. If no level is specified, it will be default to error. The additivity attributes may be assigned to a value of true or false. If the attribute is omitted, the default value of the true will be used. Capturing location information, the class name, file name, method name, and line number of the caller can be slow. Log4j tries to optimize this by reducing the size of the stack that must be traversed to find the caller of the login method. It does this by determining if the component that might be accessed required location information. It can cause performance issues if a logger is configured at the level like trace or debug within the expectation that most logs will be filtered on an appender reference. So appender as log4j will calculate the location information even though the log event is going to be discarded. To disable this behavior, include location attributes can be set to false on the LoggerConfig. This will cause Log4j to defer calculating the information until absolutely necessary. A LoggerConfig including root LoggerConfig can be configured with properties that will be added to the properties copied from the thread context map. These properties can be referred from appenders, filters, layout, etc. just as if they were part of thread context map. The properties can contain variables that will be resolved either when the configuration is passed or dynamically when each event is logged. A LoggerConfig may also be configured with one or more appender ref elements. Each appender referenced will be associated with the specified LoggerConfig. If multiple appenders are configured on the LoggerConfig, each of them be called when processing logging events. Every configuration must have a root logger. If one is not configured, the default root LoggerConfig, which has the level of error and has a console appender attached, will be used. The main differences between root logger and other loggers are: root logger does not have a name attribute. The root logger does not support the additivity attribute since it has no parent. Here the loggers root X and XYZ each have a configured LoggerConfig with same name. The logger XY does not have a configured LoggerConfig with a matching name. So uses the configuration of LoggerConfig X, since that is the LoggerConfig whose name has the longest match to the start of the logger's name. Um, as an error example, we can consider this one. C colon / program files / Java / JDK 1.0 8.0 underscore 231 / bin / java.exe d log4j1 the dot compatibility equal true, trace status logger default configuration stopping root LoggerConfig, etc. This is occurred after Log4j1 migration to Log4j2 default configuration is being used.